My name is Liz.
And I'm Charlie.
And we are members of the NRICH team based at the University in Cambridge. We're delighted to have you all here with us this afternoon. We'd like to say a big thank you to Trinity College here in Cambridge, who very kindly fund these webinars so that they're free for you to attend. I think what I might do is share the NRICH site to talk us through some background before we get going on the webinar itself. Here we go. So I'm hoping you are able to see the homepage of NRICH. In case you're not so familiar with NRICH, I'd like you just to take you to the secondary teacher landing page, which I would suggest would be your go-to place as secondary practitioners. And you'll see that the way that we have arranged, the way we've organised the website has changed relatively recently. Hopefully you're becoming more familiar. What we're suggesting is that as a mathematician, students need to be able to obviously have a good understanding of mathematical ideas and be fluent, but also it's important that we equip them with mathematical thinking skills and that we help nurture positive attitudes. So the way that we've structured NRICH is hopefully reflecting that, and it will allow you as teachers to find tasks depending on the focus that you have for your mathematics lesson. All of the tasks you get to by clicking on any of these three boxes are curriculum linked tasks, but they've been carefully selected so that you could draw out some particular, for example, some particular positive mindsets. Now, some of you may know that we have recently completed a series of 5 webinars on developing mathematical thinking, and we will show you where you can find those later. But now we've turned our attention to our positive attitudes. I'll just click on here briefly, and you can see that we've identified 4 mindsets or attitudes. We've already hosted a webinar on being collaborative and being curious. And today we turn our attention to being resourceful. So, Charlie, quite often at NRICH, we refer to an article written by Alan Wigley. And Alan Wigley, he talks about 2 contrasting models of teaching and learning. So the first model, he talks about a path smoothing model. So a teacher who adopts a path smoothing model will help students every little step of the way. So they will provide scaffolding so that the students can't possibly fail as they tackle a task, for example. And I think that feels quite natural. We don't want our students to fail. However, Alan Wigley argues that actually then we create a classroom in which our students are very dependent on the teacher, and they look to the teacher as providing the approach to solve a particular problem, and there's no room for creativity. So Alan Wigley, he contrasts that path smoothing model with what he calls the challenging model. And in a challenging model, he suggests that a teacher would start their mathematics lesson with a problem. So you offer the problem straight away. And in that way, you invite students to bring their own ideas to the table. So they might, first of all, perhaps share some ideas with a partner. And then you as the teacher, your role is to draw together the students' ideas and help the class build on them. And so I guess in this model, Charlie, we're building more resourceful learners. And I guess the way that we're doing that is we are encouraging students to bring their own thinking, their current knowledge, their current skills to the table. We're offering them a chance to be creative, to make choices, perhaps. And we as teachers are sending a message that we value students' own thinking and that we trust what they've got to bring. And I think that sets the tone for our webinar this afternoon. Before we get going on some tasks, which we hope will illustrate those points, did you want to add any more to that?
Yes, you said that it feels quite natural to want to be the teacher makes the path as smooth as possible for the students. But a couple of drawbacks that Alan Wigley talks about is that often the students only get exposed to one way of doing things, and they take away with them the message that there is one correct way of proceeding rather than many. And if we want students to be resourceful, we want them to have a toolkit full of different tools that they can draw upon and that they can decide, use them in quite a flexible way, possibly in a creative way. And the other problem is that if you have the path-smoothing model, it's often the teacher demonstrating a particular way of solving a standard problem. And even though the students may become very proficient at solving those standard problems, actually they're at a loss of what to do when the problem is not a standard problem, when things get changed. And again, if we want students to become resourceful, it seems really important that they have the confidence and feel capable of solving any type of problem that gets thrown at them, or that they have some strategies at their fingertip. And so it feels really important to think carefully about what Alan Wigley is saying in terms of, if we want students to be more resourceful, we need to give them that experience of solving a lot of problems. And only, we talk about the teacher only doing for students what the students can't yet do for themselves.
Absolutely.
So your idea, what you said about students not becoming too dependent on the teacher.
So we have created a guidance page on the website, which we will show you at the end of the webinar. But we'd like to reassure you that what we hope to do in the webinar is work on some tasks which draw attention to the points and illustrate the points that we've written in the guidance. So we hope you won't feel the need too much to make reams and reams of notes. And we'll come back to that later, as I said.
Yes, in a way, this webinar is an excuse to publicize the fact that we've been thinking about resourcefulness for the last 4 or 5 weeks, and we've tried to synthesize our thinking in our guidance notes, which we hope will be useful for you to return to, but also in particular might be really useful for you to share with your colleagues.
Absolutely. Okay, so Charlie, I think it might be time to have a go at some tasks.
And I thought that the first one that we might look at is a task called cryptorhythms, which is on the mapping document. So,
right, yeah. So if we go back to the secondary teacher landing page, if we want to find the mapping document, we can choose the curriculum linked.
Yes, because most teachers are planning lessons based on what's on the curriculum.
Absolutely. So we'll follow this link here.
And we've organized the curriculum into 4 sections: number, algebra, geometry, statistics and probability. And the first problem is a number problem. It's to do with calculate number operations, I think.
Okay, so
if we scroll down, there it is, number operations. And then you should find cryptorhythms there.
Yep, I can see that one.
Okay.
Click on that.
And here you're given letters to represent the different digits. And of course, the letter A in question 1 doesn't bear any resemblance to A in questions 2, 3, 4, 5, and so on. Each question stands alone.
Okay, that's important to know.
And the challenge here is for students to use what they know about number operations and about place value and about the properties of numbers to figure out what the letters stand for.
Okay.
So Liz, how about looking at question 4 initially? I think question 1's too easy for you.
Question 4 is this one at the top here. Okay, right. So I take stock for a moment. So I notice I've got a 2-digit number plus a 1-digit number, and I'm ending up with a 3-digit number. And so I think that this 2-digit number has got to be 90 or more. It's got to be, no, 91 or more. and I'm given a 1, and this C has got to be 1 for 100. So I think I can confidently say we've got a 1 here, 100. Well, that means actually the ones in the answer is 100. So I've got 90 something plus 9 is 1 something 1. Okay. So if I know that, is this making sense so far?
It is making sense. And presumably
Okay.
the D can't be 7 or 8 or 9 because you wouldn't be able to get 171.
Very good point. Okay. So let's think. If I know that this digit here, this number here plus 9 is giving me a 1 in the units, in the ones, well, I guess, what about 2? I mean, if B was 2, I think that would give me 92 plus 9. I would get a 1 here.
You get 101.
I'd get 101.
Okay.
So D would be 0.
Okay.
So I think that's the solution.
So one could say to students, add a 92 plus 9.
You could.
And that would be done in a very standard way.
Yeah.
You've had to be a lot more resourceful.
I certainly have.
Solving a problem like this.
Yeah.
You've had to make decisions about which clues to use and in what order. Mm. You're still being challenged to demonstrate that you know how to add and you know something about place value.
Yes.
But at the same time, I'm forcing you to think a little bit harder.
Definitely.
And I think all the questions that we're going to be doing today will be of that sort. You found that too easy to do, so I'm going to... Do you want to have a go at question 10 here?
Question 10. Right.
So AB plus AB equals CBB.
So here I'm thinking, okay, if I look at this sort of globally, if you like, I've got a number multiplied by 2 is a 3-digit number. So my immediate thought is, well, you know, I've got to have 40 something.
Would you get a 3-digit number?
No, I'd have to be 50 something. I'm drawn by also the fact that B here and B here is giving me B here.
So what could be B?
Very good. Well.
Could it be 7?
No, because then I'd get a 4 here.
Could it be 2?
No, I'd also get a 4. At this point, and I see what you're doing. You're trying some examples. I might try a bit more systematic in what I'm trying. So I might, well, the lowest it could possibly be would be 0. 0 plus 0, 0. So I'm thinking that 0 is a solution, which would give me 50 plus 50, and then I'm going to have a 0 here.
Okay. So
that feels good.
Okay. And you could think a little bit more about, is there more than one solution?
Yeah.
In some of these questions, there are more than one.
Okay, yeah, we haven't done too much.
But this is an example of how one can turn a fairly mundane, boring set of questions about adding into something a little bit more interesting, which requires you to be quite resourceful. And you know, I'm not going to give you question 23 to do right now. That's your homework, but can become more challenging. Okay. Nice. So now I think let's stop sharing for a second.
Yes.
So we chose that partly because part of being resourceful is having to make some decisions about where to start, how to connect with all the information.
That's right. I felt like I had knowledge and skills I could bring to the table, but I just wasn't quite sure what was going to be immediately useful. I think.
And it might be a bit messy as you go along, but you weren't panicking and you weren't saying, "Oh, I don't know the answer straight away." And to be resourceful, I think you need to be prepared to sort of get your hands dirty a little bit.
And you need to have a bit of that self-belief. So I think one of our roles as teachers is to believe in the students themselves and help them develop that.
Yes, and not worry about having to experiment a little bit.
Exactly.
Okay, so another way of getting students to be resourceful is to put obstacles in their way.
Yes, in the nicest possible way.
Yes. And so the next example that I'd like to share is imagining that you're doing some work again on number operations, but this time students using calculators. But unfortunately, the calculator that you've been given is not working very well.
Oh.
So can we share the visualizer?
There we go.
Okay, so you've got a calculator. Unfortunately, only 6 of the keys work.
That's a pretty rubbish calculator.
It is. So again, the 4 and the 5 work.
Okay.
The subtract and the multiply work.
Yeah.
The equal sign work, and you can cancel at any time and start again.
Right. Okay.
So you want students to be working on operations and use their understanding. So the challenge that we have for everybody is this. Which of the numbers from 1 to 20 can be the solution to a set of operations on your calculator? How can you get an answer of 20, all the numbers from 1 to 20 on your calculator if you're only allowed to use 4, 5, subtract and multiply, equals and cancel? And what we'd like you to do is, in the chat, go writing as you find, so
a solution.
Yes. So yes, you might decide, I can do 16, but I can do 4 times 4, for example. Stick it in the chat, and we'll give you a minute or two to do that, please.
Yeah. Okay.
Parentheses are not available, I'm afraid. And somebody's used the addition sign, which is not allowed.
No adding button on this calculator. So remember, we don't have any brackets. We've only got the keys that Charlie has popped at the top of the piece of paper. No, we're definitely not allowed powers, Susan, I'm afraid.
Somebody's written that multiples of 5 and 4 are easiest. 4, 5, 8, 12.
I wonder how.
Yes, I'm curious about why you think that. Okay, I do have 6 problems I want to show all together.
So I'm afraid we're not going to give you so long to think about this. But Charlie, I guess what would you hope a particularly resourceful student might do when faced with this problem?
Okay, so we often think that we need to cover the topics in the curriculum.
Yes.
Children need to learn how to add and multiply and solve equations, because being able to solve equations makes them more resourceful and it enables them to solve certain kind of problems.
Yes.
Being able to multiply fractions is going to be really useful, because then when they're doing some work on probability, it's going to. So, of course, the content of the curriculum is really important.
Yeah.
On the other hand, there are other resources that they can draw upon. And in this case, perhaps sort of being strategic or being systematic can be really useful. And I did notice that somebody said, "Oh, this is easy. There are some sort of things that are easier." And I'm just thinking, what I might do is I might start, for example, with 4 times 5 equals 20.
Yeah.
So I can do 4 times 5 and I'll get 20.
Yes.
But once I know I can do that,
yes.
I can take 5 away and I can do 15. I can do another 5 away and I can take 10. I take another 5 away and I get 5.
Yeah.
But I could also have taken 4 away.
Yes.
I could have got 16. And then another 4, 12. And another 4, 8. And another 4, 4.
Yes.
And perhaps this is what, I can't remember the name of the person who said it, why these were quite easy.
I think it was.
But I could also presumably, from 20, take away 5 and then take away 4. So take 9 altogether.
Take 9 away. And then another 9?
And then I could take away another 9, which would take me to 2.
2. Yes, nice.
But from 11, I could have taken 5 away, which is 6. Or I could have taken 4 away, which is 7.
Yeah.
So just from 4 times 5, I am working in a really mathematical way.
Yesterday in the primary webinar, you mentioned this, Jeff Foltz, who was very active in the Association of Teachers of Mathematics, the ATM. He talks about, and I'm not going to be able to phrase this quite right, but he talks about getting a lot from a little.
A little. Yeah. So from 4 times 5 equals 20, I've been able to get 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11.
More than half. Yeah.
So then I'm thinking, wait a minute, where else could I do? What else could I do?
We've got some suggestions in the chat.
Right. So I can't see that. Aline?
Aline or Eline? Yeah. I'm not sure. Sorry, apologies for not pronouncing your name correctly.
Okay. So has started with
55.
You can start with 55. I'm hoping that you can see what I'm writing. And basically, I don't want to start at 20. I want to start somewhere near 20. But so I might take away some 5s.
Yes.
So I get to 50, I get to 45, I get to 40, I get to 35, I get to 30. But then I might take away 4 and take away 4, and I end up at 22.
Right. So you've stopped at the point where you get to 30. You've now changed to taking away 4s rather than 5s.
So that I end up not at. I don't want to end up at 20.
5. Yes.
But from 22, I can start doing what I did before. I can take away 4, and another 4.
Yes.
Another 4, another 4. Or I could take 5s. I'd end up with 17.
Yes.
And then another 5, 12, which I've got. Or from 17, I can take away 4.
Yeah. Woo,
and
so close.
And we're nearly there, aren't we?
Yes.
From 13, we take away 4. And not quite, but from 9, we can take away 4 and then another 4, and we get to 1. And okay.
Yes.
I'll stop there. I'm sure we can get 3 and 19.
Yes.
But the point, I think, is that it is really, I can imagine as a teacher wandering around, and initially students are working at things quite randomly.
Yeah.
I think in the same way that we set aside some time to work on fractions or simultaneous equations or angles and cyclic quadrilaterals, I think spending a bit of time on working strategically and so on. I think resourceful people find ways around problems that make them easier. And here's
a lovely example.
Lovely example.
Absolutely.
Okay.
Yeah, absolutely. So, next problem. Shall we go back to the mapping document?
Yes,
Shall
please. Yes.
Yeah. Okay, let's stop sharing the visualizer. Go back to the website. Here's cryptorhythms. Let's go to, back to the, oh, we've got quite a large mapping document now. Reduce it down. Now, this second problem, third problem we're on.
If you scroll down, I think in the number section of the mapping document, there's a section on ratio. And in ratio, we've got a problem called mixing lemonade. And I think we might have got a tab already open for mixing lemonade.
Let me just move a few things around on the screen so I can actually see my tabs. That's better. Okay, have a look at this one first. Okay,
I'm going to move this completely out of the way.
Yeah, I do.
So in this problem, you've got two containers, two jugs or two glasses, and you have some lemon juice and some water. In the example that we've been given here, the one on the left has 200 milliliters of lemon juice and 300 milliliters of water, whereas one on the right has got 100 milliliters of lemon juice and 200 milliliters of water. And we could think about which has got the stronger taste of lemonade.
Okay.
And students may approach this in different way. You might think, oh, if I've got two identical right-hand glasses, instead of having one lemon and two water, you could have two lemon and two water. And four water.
Yeah.
So both left and right would have the same amount of lemon, but the one on the right would have more water. So that would not be as strong. But other people might say, the one on the left, 40% or 2/5 is lemon, whereas the one on the right, only a third. And so that's another. So there are and there are more ways in which we could do this. There are a variety of approaches. And it seems to me that one of the messages we want to give out is that students can approach problems in a variety of ways.
Absolutely.
So here we go. We have an interactivity, and you click on new mixes, and you get given different beakers, beaker A and beaker B. So in the first example, in this example, beaker A has got 10 units of lemon juice and 60 of water, and beaker B, 50 of lemon and 480 of water. Could you post in the chat how you would decide which one has got the stronger lemony flavor? So don't just say beaker A or beaker B. Please justify your conclusion. That's wonderful. There are many more ways than we had originally anticipated.
Absolutely.
I think I'd thought about multiplying everything in beaker A by 5. It's sort of having 5 identical beakers and putting them into a jug, because then I would have the same amount of lemon in both left and right.
Yes.
And if I multiplied everything by 5 in A, I'd end up with 300 units of water.
Yeah.
So the 2 beakers would have the same amount of lemon, but beaker A would have a lot less water. So some people suggested that, but some people also suggested multiply beaker A by 8, because then the amount of water would be the same in both beakers. And again, they would compare the amount of lemon. But a lot of you are looking at percentages, what fraction of the beakers are lemon, what fractions are water, and it could be fractions and percentages and decimals. We've got a second example to show you. Why do you think we chose this example? What's interesting about this? Because this is slightly different, and of course, it can still be solved using a lot of the strategies that you've already been describing. But perhaps there's also another strategy that wasn't so obvious for the first mix. Actually, we haven't got all that much time. No. I think I'm going to get...
True.
Yeah, okay. So sometimes it depends on the numbers, and it took us several goes at clicking on new mixes before we got this one, is that the amount of liquid in beaker A is a multiple of the amount of liquid in beaker B.
Yeah.
So beaker B has got 110 units of liquid, and beaker A has got 5 times that amount. So because the totals can be made identical, so you could multiply beaker B by 5 and get 50 and 500, and you've got the same amount of liquid in both. You can then see how much is lemon and how much is water.
Yeah.
And when I've done this with classes with students, I've often talked about the different methods and associated them with the person who first suggested that.
Right.
So we could have Gary's method and Liz's method and Benjamin's method and Amy's method for all the variety. And then what's quite nice, I think, if you go to the teacher's resources, we have a worksheet with a variety of mixes. And I might ask the students, okay, which of these questions lends themselves to be answered using Gary's method?
Right. So if I had this in beaker A and this is beaker B,
would I use Gary's method?
Yeah.
And then look again, maybe ask Liz again, rehearse your argument. Okay, which ones would you use? In which ones would you use Liz's method? In which ones would you use Benjamin's method? In which ones would you use Amy's method? And of course, some mixes, combinations, lend themselves to be used in more than one way.
Yeah, but I guess the point here is that if we are sharing a variety of strategies with students and we are drawing their attention to the fact that they have a choice and that they may choose, the method they choose to use will depend on the particular numbers that the problem includes.
Yes.
Yeah.
Okay, we're going to go straight to another problem. It's in the secondary mapping document. I hope you can, yes. And it's part of algebra this time. So I'm going to click on algebra. And I think it's to do with equations and formula. Here we are. And it's called, which is bigger? And I've got a tab open already. So go there. Liz, the problem starts with which is bigger, n plus 10
Yeah.
or 2n plus 3?
Okay. Well, I would say n plus 10. Because I expect you're going to ask me why or
Come on then.
how I know. Because if n is 1, then n plus 10 makes 11, but 2n plus 3 only makes 5. So I would say n plus 10 is bigger.
But what if n is 100?
Okay, if n is 100, then n plus 10 is 110. 2n plus 3, becomes 203. So actually, for n is 100, it's the other way around. 2n plus 3 is bigger. So there's more going on here than I first thought.
Okay, so back to everybody who's taking part in the chat. How could you resolve this dilemma? Liz has noticed that sometimes n plus 10 is bigger, sometimes 2n plus 3 is bigger. How do you answer the question, which is bigger? How might you solve this? How much you want your students to solve this?
Yeah.
And is there a range of possibilities?
The solutions are coming in thick and fast, or some suggestions coming in thick and fast, I should say. And we've got a range of suggestions, which is very nice.
So Dan, let's assume that they don't know any algebra. Can they still solve this problem? And somebody who's posted that it depends on whether n is greater than or smaller than 7. How did you get at that?
Where did 7 come from?
Yes, why 7? And so in the guidance, we've emphasized the importance of students justifying the decisions that they come to, and that how important it is to set aside time in the classroom to articulate methods and thinking. Yes,
that's
Dan.
nice. Yeah, I like that swapping point. That's a nice, nice way of putting it.
Yes, and Matthew's also suggested something similar. No, Matthew suggested solving an equation. Okay. Okay, again, I'm going to stop there because I've still got 2 problems I want to show you. I think this can be done by trial and improvement, Liz. You could have carried on and said...
could have said what happens if n is 2, 3.
And then n plus 10 is still bigger, but and what if n is 3? So I think for some students, there is slowly, systematically getting it. Some people talked about drawing graphs of, for example, y equals x plus 10 and y equals 2x plus 3, seeing where they meet and finding that x equals 7 they meet. Some people talked about solving the equation n plus 10 equals 2n plus 3. And we could be resourceful if we appreciate the connections between algebra, graphical representations, and so on.
Yes.
And so this lends itself to that. And then there are more examples in this problem. And then it gets a bit, slightly harder.
A bit more of a challenge there.
Here's some challenges. For example, find 3 expressions. So the first is biggest when n is smaller than 0. I'm looking at the second bullet point here. Sorry, I didn't make it clear. Sorry. Find 3 expressions. So the first is biggest whenever n is smaller than 0. The second is biggest when n is between 0 and 0 and 4. And the third is biggest whenever n is greater than 4. So again, where I can imagine doing that graphically initially, and then finding some equations and so on. But again, the message is, as in our webinar on multiple representations, you can do things numerically, you can do things graphically, you can do things algebraically. And if you've got all 3 tools in your tool bag, then you're much more likely to be resourceful. If one doesn't work, you try another.
Absolutely.
Right. What do I want to show you next? Sorry, I want to go back to the mapping document, and I want to go to number again, and I want to go back to operations. We've got a problem called sealed solution, which says, here's a set of 10 cards. So we've got 0 to 9. And the 10 cards are divided up between 5 envelopes. And in each envelope, there are 2 cards. And the numbers in the first envelope add up to 3, in the second add up to 7, in the third add up to 8, and then the last 2, 13 and 14.
Yeah. And
the challenge is to figure out, where did the digits 0 to 9 end up in? I'm going to just give you a minute to think about how you would approach this. What would you do first? And maybe share that. I'm not going to give you time to solve the problem.
No.
But maybe think about, what would your first gambit be? What?
Yeah.
Because sometimes it's worth thinking about that and sharing that before letting students loose.
Yes, Juliet, there are exactly 2 cards in each envelope. Yeah. Thank you for your suggestions so far.
Can we have an envelope, please? Sorry, the visualizer?
Yes. I'm going to stop sharing the website, and we're going to go to visualize again. Charlie is scribbling away here.
Try to summarize the information.
Nice.
In the same way that having being able to visualize things using multiple representations, and in the spirit of, it's not just the curriculum topics that are what teachers want to share. Andy has mentioned the value of appreciating the tree diagrams are a useful resource. And in this case, it seems to me, could be really useful.
Yeah.
So I think Dan noticed, I mean, a lot of you started with the envelopes at either end.
Yes.
Because
the 3 or the 14.
There were fewer choices.
That's right.
And it was difficult. If you want to work out what goes in the envelope with the 8, well, it could be the 0 and 8, or 1 and 7, or 2 and 6, or 3 and 5.
There are a lot of possibilities there.
Whereas if I go for the first envelope, I know that I've got to have either 0 and 3, or 1 and 2.
Yes, there's no other way you can make a total of 3.
No.
Okay.
And perhaps, so that's my 3 envelope taken care of. And I might then go for the 14, because again, I suspect that there are not many choices.
Exactly.
So for 14, I can have 6 and 8.
Yeah.
Or 5 and 9.
Right. And both of those are possible with 0 and 3, because we haven't used any digits twice there, have we? So at the moment, we've got 4 different possibilities.
Yes.
Okay.
I'd be tempted to go for 13 next.
Because that feels like it's got fewer than
because
7 and 8.
It's going to use big numbers.
Good point.
And so for 13.
Right, 13.
9 is the biggest.
Yeah.
So 9
and 4.
I'm going to just make a note here. 9 and 4.
Yeah.
9 plus 4 is 13. Or
8 and 5.
Or 7 and 6.
So those are our options, I think, for
okay.
13. 9 and 4 we can do. We can 0 and 3 and 6 and 8, can't we?
But I can't do 8 and 5 because I've used. I can't use 7 and 6.
Because you've already used.
So that can only be 9 and 4.
That feels very satisfying.
I can't use 9 here.
No.
I can't use 5 here.
No.
So that can only be 7 and 6.
Good.
I can't use 6 here.
No.
I can't use 8. So this can only be 9 and 4. I can't use 9 here. I can't use 5. I could use 7 and 6. So I've still only got
4 possibilities.
And I could carry on like this. I'm going to stop because I do have one more problem I want to show you, even though it's 4:48. But I can see that this is something that is worth sharing with students and for them to start appreciating that. I want them to leave the classroom not thinking, oh, I've got something else to learn.
Right.
I want them to leave the classroom thinking,
hooray,
oh, that's a new tool that I can use. And of course, we often use tree diagrams when we're doing work on probability, but I think it's quite useful to introduce tree diagrams sooner.
Yes.
And I think
top
teachers in primary.
Yeah, definitely.
And you can then start, the rest falls into place. And what's lovely about this, I also think, is that at the end, you have found all the possible solutions.
Yes. We have not missed anything out.
Yes.
Yeah.
So there is that kind of, so in the guidance notes, we have written about the importance of having a bit of time at the end of a lesson, a plenary session, where we draw, what are the key ideas that have come out. So I do expect students to work very randomly to start with.
Of course,
in the way that Alan
we have leapt straight into this, haven't we?
Yes. But it seems to me, offers an opportunity for thinking about how can I be more systematic. And working systematically is a resource that I want to make use of. Okay, very, very quickly.
Last problem to take a look at. Let's go back to the website. So this one is also on the mapping document, isn't it, Charlie? Sorry, I'm being slow.
It's also in the same section on equations.
Okay. So go back here.
And I think it's in a year 10 problem.
Okay.
And it's called warm snug double glazing. So it'll be
going down. Oh, hang on a second. We're in number. I think actually it's an algebra.
It's an algebra. Yes.
Yeah, that's why we can't find it. Yeah, here we go. Keep going, keep going, keep going. Here we go. Warm snug double glazing.
Yes. You've got it in the right hand. Yeah. Okay. And here you're told that the price of these windows depends on the amount of material used for the frame plus the amount you had to pay for the glass. So the area of the glass and the amount of frame determine the price.
Okay.
Unfortunately, there is one window that is being incorrectly priced, to make things
very cruel.
But what's quite nice is, a bit like in cryptorhythms, there are lots of, you've got more information than you need.
Absolutely.
But you then have to sort of try and figure out what's best, what information is the most useful. And what students often do is they start by working out the perimeter, and in some cases adding also the bars that are in the middle of a window and working out the areas of the window, and then starting to look at, for example, notice that window C, which is 4 across and 2 along, and window F, which is 3 and 3, will have the same perimeter.
Yes.
But
different in area.
Slightly. F has got an area which is 1 square greater than C, and so you can get it to so that must be the reason why the cost of F is, and you can start making conjectures. I mean, of course, it may be C or F that may be mispriced.
Price one, yes.
And we do have in the teachers' resources a worksheet. Is it in here?
Maybe it's in the problem. Is it in the problems?
Maybe in the getting started.
Yes.
So what did we look at? CNF, I think,
Yes.
had the same frame length and different areas. But you could look at windows which have got the same area. Here's one with an area of 12 and another with an area of 12 and different frame lengths. And can we share very quickly the visualizer?
Yes.
So I could imagine starting to say, oh yes, we could use C and F because they've got the same perimeter or frame.
Yes.
But there was also another one, I think I've got a copy here of, there were two which had the same area, I and O. Am I right? Yes. This is a 3x4.
Yep.
And this is a 6x2. So you could compare these two because they've got the same area. Are there other combinations that you could use? You get into sort of conversations about, oh, just like we did with mixing lemonade.
Yeah.
Because I've got here, H has got an area, H has got an area of 3.
Yep.
Area equals 3. And I've got, for example, B has got an area of 15. And I can start thinking like I did with mixing lemonade.
Yeah.
Oh, if I multiply that by 5, what?
Have the same area.
They'll have the same area. What is the difference in perimeter?
Yeah.
And sometimes I might have, 6 of. We started the same kind of conversation. We had with mixing lemonade.
There's so much choice here, though, isn't there? I think that having to make those decisions for ourselves.
And like with a calculator, I might say, okay, you're not allowed to use that. You're not allowed to use that. You're not allowed to use that. Not allowed to use that. Can you find another pair that you could use? And slowly restrict it.
Yeah.
If I give you randomly any pair, or if you select any pair randomly, can you find a way of deciding on the price?
Yes.
And that, it seems to me, builds up those resourcefulness and muscles, because you're having to think differently, and you have to perhaps be quite creative.
Absolutely, you're not going for the immediate, the obvious option.
Right. We did all 6 problems.
Wow. To the end there. Thank you for sticking with us. We're going to stop sharing the camera and we're going to go back to the website just to show you where you can find the guidance that we've created and the links. So if I take you back to the secondary, let me make that a little bit bigger again. If we go back to the secondary teacher landing page and click on developing positive attitudes, you'll see as you scroll down, we showed you this, we've got our being resourceful secondary teachers page here. And what you've got on this page, just first of all, is a link to collections of tasks which lend themselves to different ways of being resourceful. And each collection links to the year group curriculum objectives. So that's a good starting point. And the guidance that we've written, you can see in this blue box at the top. If I click on that, let's just take you through that quickly. We've structured this in a very similar way to the previous guidance we've written. So we begin by setting out our values and ethos, so what we believe about mathematics teaching and mathematics learning. And that will influence then the structural considerations for our classroom. So we talk here a little bit about, we talked right at the very beginning of the webinar about Alan Wigley's model, and you can find a link to the article there. Charlie has mentioned the fact that we are giving high priority to students articulating their ideas, and there's a link to Voice 21, which is an Oracy project. We're highlighting this idea that we're inviting students to look for a way. It's not about guessing the way that's in the teacher's head. And if there are multiple ways, if students understand that the teacher is valuing multiple ways of reaching a solution, that reduces the anxiety. They're not looking for a single way, and they're much more likely to be successful. We've talked about being flexible and creative, and I think this is an important point. And as teachers, if we are thinking about the way we are, feeding back and assessing during lessons, then thinking not just about the assessment in terms of the curriculum knowledge and skills, but actually appraising students on their willingness to work in a mathematical way is really key here. And this last section gives you some prompts, some questions which you might use to encourage students to become more resourceful, some general questions. Finally, I've mentioned already the collections of tasks which are linked to year groups, but what we've done here is we've specifically pulled out some tasks that illustrate the value of different ways of being resourceful. This first set is about valuing multiple representations. The second set is about working systematically, and the third set is about overcoming barriers. And you will recognise, I hope, the name of some of the tasks that we have worked on in this afternoon's webinar. Finally,
there are some references at the bottom.
I beg your pardon. There are some references at the bottom if you'd like to go to read further. It's just occurred to me, Charlie, would you mind just getting the feedback form link?
It's already there.
You're such a star. It's good. Thank you so much. Is there anything else? Oh, I know what I wanted to say. This recording will appear at the beginning of next week at the top of this page. So you may find it useful to refer your colleagues to the page. They'll be able to watch the recording of the webinar and read the guidance themselves.
And there'll be an email telling you once it's there with a link to it. But if you need to know how to find it, you go to the Secondary Teachers page, you go to Developing Positive Attitudes, and this is about being resourceful, and that's the page that Liz has just been talking about. Sorry, this is the page that Liz has just been talking about, and that will have the link to the webinar.
Exactly. Thank you very much for your participation this afternoon. It makes our lives lots easier when you are so ready to contribute. We hope you've had a useful afternoon.
Please give us some feedback.
Please complete the feedback form.
We share that with our funders,
We do indeed.
And it's really useful to have positive feedback. No, critical feedback is also useful because then it helps us improve.
Exactly.
And in the long run, we get more positive feedback. So do please be honest. Yes. We look at the feedback really carefully.
Thank you. Have a lovely rest of your day, everybody. And we hope to see you at a future webinar, which will be June the 18th, when we're going to be focusing on resilience.
Resilience.
Yeah. Thank you. Bye for now.